When system development still allow.
People are joining already. Well, maybe you need to go back. Prof might have joined. Go to.
Hi, everyone. Can we unmute our mic as we prepare to join the meeting? Thank you.
We can hear you very distinct. Include the video.
All right, I think it's good we start now so as to save time and enable us to meet up with our agenda for this afternoon. Good afternoon, everyone. We are welcome to today's webinar series by OFAB Nigeria. It is our delight to host you all, and we hope that you find it very interesting and very evoking. And to start with is the introduction of guests by the moderator in person of Professor E.H. Kwondong. Hello, Prof. Hello, Prof. Prof, can you please enable your video?
Okay, it's not me.
Okay, can you? Hello?
Yes, Prof.
Yes.
Can you enable your video?
It's our own now. Yes, sir.
Prof, please enable your video.
Okay. Which prof are you referring to, please?
Professor Emmanuel Kwondong.
Okay. No, okay.
Hello?
Prof.
Hello, can you hear me?
Yes, you are still here to enable your video, sir.
Here it shows me enabled though.
All right, maybe.
The video is showing me here. Enabled.
Prof, we can't see you.
Huh? Let us finish with this thing. I'm not connected now. This is Alex Babutu, not me now. Okay.
Okay, maybe
Who is that?
I go on to do the introduction of guests.
Okay, I told him to hold on a bit.
Can you see me now?
No, Prof, we still can't see you. Just enable your video. Click on the video icon, and it will be turned on rather.
I'm not sure I can wait for this thing.
The network.
Hi.
Okay, while Prof C prepares for his own part, we would want to have the DG CEO of the National Board for Development Agency, NABDA, in person of Professor Alice. You're welcome, sir.
Yeah, thank you very much.
So, sir, we want to have you do the opening remarks.
But most of the members are not here. Most of the things are still empty.
They are, sir. We are seeing several participants here from our side. You may not see them because you are participants, but the hosts are seeing them.
Okay. Well, I welcome you all to this webinar series. Of course, we know that the COVID-19 pandemic has created a massive problem in the world, and also here in Nigeria. And as a result, science and everything else, business, has also had some changes, and has had also to adapt. So I welcome you. This is an opportunity for us to continue to interact, and especially to focus on biotechnology and what it can do, and what it can be used for in times like this. But we all do know, as practicing biotechnologists, that this time biotechnologies are a tool that is basically extremely important and extremely useful, not only to Nigeria, but to the whole world. Now, if you look at it in the area of health, there's no way you can do vaccines. There's no way you can do diagnostic kits and even biopharmaceuticals without all these biotech products. So you can, like in NABDA, right now, we have been able to successfully, with our technical partners, the University of Sheffield, to develop an RNA-based test kit, which is the first of its kind in the whole world. It's a purely African program, African project, African test kit, and will soon be unveiled formally to the whole country and to the whole of Africa. You find also that apart from diagnostic kits, vaccines, which everybody, more than 100 countries now are working on vaccines for COVID-19, including Nigeria, will soon start unveil to Nigerians and the world our efforts in the area of vaccine production. You find that biotechnology has other applications, even in agriculture. It's massive, and that is where most of post-COVID activities coming. You find also that here in NABDA, using biotechnology, we've been able to impact also massively and plan to impact, and started impacting massively in the area of agriculture. If I may just give one or two examples, our yam modification program, last year we were able to, using aeroponics, to do close to 1 million yam seedlings. And this year, but for the lockdown, we're targeting about 5 million yam seedlings. And all these are feasible because of biotechnology. So it is an extremely important science for us. The times are such that we cannot no longer have our usual conferences and meetings where we learn from each other and then we learn the latest developments. But this series still enables us to be able to meet, to hold, exchange ideas, and exchange knowledge, and continue to work together. And that's why I'm doing this opening address. I might not be able to stay to the end because we have a lot of things on my hands. As I said, tomorrow, the Honorable Minister of Science and Technology is formally launching our RNA test kit, which has been validated by NCDC and by activities here in NABDA, and also validated down there in the UK by the University of Sheffield. So I might not, as I said, might not be able to stay to the end, but I wish that the meeting will go successfully, and that at the end, Rose and her team will give me a full report of how it went. I believe it will go well. I've already seen my very good friend, Professor Chedozie Gessi, and Babajide is there, and Collins, Nabifeda, and all the other great guys around. I know all of you will do justice to this program. Thank you very much.
Right. Thank you very much, Prof, for that wonderful opening remarks. It was really great having you, sir. And a successful meeting tomorrow.
Thank you.
Please, can I break in? You didn't introduce people, you just started.
Professor Kwanda was supposed to do that. So we reserve that section for him when he comes back online. I think he has issues with his video. But then I think
even without that, people's names are clearly shown. I can see Professor Gessi and all the others with their names are clearly spelled out. I don't know, but maybe formal this thing might still be necessary. But I think I can see the names of all the participants, those who are here at the present time.
Okay, sir.
All right, thank you very much.
All right, thank you very much, sir.
Thank you.
So up next is the presentation by Dr. Dilado on curbing the COVID-19 virus using biotechnology. Doctor, it's up to you.
Okay, so I have a PowerPoint presentation.
Okay.
So I don't know, I should share the screen.
Yes, you can. Yes, you can.
All right. So how do I share? I'm coming.
Just at the title bar, you will see share screen. So you can click share screen, ma.
I'm coming. I'm trying to do that. Wow. I can't see that here.
Maybe.
Okay, I've seen it.
Okay.
It's disabled though. You are disabling me. It's telling me that the host is disabling. Host disabled screen sharing. I think Professor Kwandun is on.
Okay, it's on now. So,
Prof. Yes, maybe you can do without video. I don't know. It's not possible.
I'm surprised. My video here is showing enabled, but from what I understand, you are not hearing me. I mean, you are not seeing me.
Yes, we're not seeing you, but you can talk.
You can just go on.
Did you just finish?
Okay, so we are all welcome.
Yes.
I had the DG, and we appreciate the DG's comments. Actually, the pandemic caused by COVID-19 is something that is of very serious concern to all of us. Needless to say that it is something that we have to live with. And we appreciate OFAP for coming up with this exciting webinar. On the list of participants, we have the chief host, the DG, who has just given his address. And we have Professor Gessi will be coming up to talk about curbing the virus. Sorry, Dr. Rose, please, will be coming in to talk about curbing the virus the biotechnology way. She will have just 10 minutes to do that. And
Wow.
she's here with us. We have also Professor Chidozie Egezi from the National Root Crop Research Institute, Umudike, who will talk to us about boosting immunity to infectious diseases. And the Dr. Polo of the AATF will give us an insight of the general perspectives on plant genetics and boosting immunity. Then we'll all go through a question and answer section, and there will also be a closing remarks. But meanwhile, we intend to have a communique at the end of all the presentations. And as it were, like I said earlier, the reality is with us. As at yesterday, the number of cases in Nigeria is about 29,789 cases with 669 deaths. And I think we have experienced cases where the death rate is even becoming more of an elite affair. Most of the people that are dying are people that are highly placed, and it's a great concern for all of us. So this topic is very good in bringing out how the potentials of plant-based treatments for this COVID-19. And I'm sure our speakers will be able to give us an insight into the prospects of the therapeutics that we can gain from all the plant-based treatments, especially with respect to genetic modification. So please, we would like all our speakers to keep to time. So Dr. Rose, we will allow you to use 10 minutes to give us your presentation.
Okay. Thank you so much, Prof. And good afternoon, everyone. Abraham, I don't know if you can share it from there, because here it's not possible. The host
All right,
is not allowing.
Let me try to make you a host, but I also try to share.
All right.
But you can go on while we try to fix that up.
All right. Yeah. Okay, now let me continue. The topic here is, anyway, I don't have time to really greet everyone very specially, but you are all specially welcome. The topic here is curbing COVID-19 pandemic in Nigeria, analyzing the role of plant genetic modification in boosting immunity against infectious diseases. Of course, it plays a very vital role. The plants play a very vital role, and so on and so forth. And I know we'll hear more details from Dr. Egezi, who has been involved in a biofortification projects. I mean, for the past, I think, 15, 20 years, either 15, 16 to 20 years. So introduction, the search of the fourth industrial revolution, otherwise known as Industry 4, is characterized by a fusion of technologies that is clouding the boundaries between the digital, physical, and the biological space. So the onset of system biology by the end of 1990s and the emergence of synthetic biology in the early 2000s has caused an alteration in the pattern by microorganisms and even higher living organisms were used as agents for industrial scale transformation. I think I have a diagram here, but we still need going into details. So the genetic engineering technology is actually one of the powerful tools of the 21st century that can revolutionize the world system and solve basic problems such as hidden hunger. Hidden hunger is a killer disease, and then climate change, and then the more recent coronavirus disease. Of course, we can only use plant, genetic modification generally to actually mitigate and this very big challenge that we're facing. So scientific findings have revealed that various bacterial and viral infectious diseases, including COVID-19, are greatly suffered by undernourished people around the world, because the lower, those undernourished people have very low immune system, and so the lower. Hello, who is that? Please, can you mute your screen? Can you mute your mic, not your screen? Mute your mic, please. Thank you. So, with an estimate of 226 million undernourished people in Africa and 5.1 million malnourished people in Nigeria, the continent is at risk, high risk of increasing its chances of being ravaged by the COVID-19 pandemic. Malnutrition intensifies the impact of every disease, including the novel COVID-19, which appears to be especially deadly for people. So malnutrition is actually one of the major pre-existing conditions that adds to the risk of the several thousands people falling ill from COVID-19. You will always hear that the disease is more, severe in those people who have other pre-existing conditions like asthma, asthma and other things, diabetes, hypertension. So I think malnutrition is also one of those things. And most of our children here in Nigeria, I think most of them, a very high percentage of them suffer that malnutrition. So it adds to the risk and so on and so forth. And that is why we chose this topic, actually, how biotechnology, how plant genetic, engineering can help in mitigating this big challenge. So, because the lower your immune system, the low immune system leads to very severe weakening of your systems and what increased likelihood of getting ill and then staying ill and dying because of illness. So I have a diagram here that shows you, under nutrition, it classifies the different stages. Poverty also leads to undernutrition, because if you're poor, the chances of you getting balanced diet to eat, are very, very slim. And then it affects your immune system. So your immunity goes low. And then it now makes you prone to some of these diseases, infectious diseases, like the coronavirus and other infectious diseases, and then mortality, it leads to death and all those things. So access to healthcare is another thing, and then social support and all this. So we need all this, in our systems in Nigeria. We need to really make people to have access, put in infrastructures for all these healthcare systems, the social support, the palliatives. The palliatives are enough. Our population is actually very large, so it's really difficult for people in those areas to have access to some of these amenities. So the link between malnutrition and immunodeficiency has been underscored in this. While diet constitutes a critical determinant of immune status, immunodeficiency is caused by malnutrition worldwide. And then the holistic success of the Nigeria's COVID-19 response team is dependent on protecting the most vulnerable members of the society from hunger and malnutrition, in addition to encouraging regular hand washing and the social distancing. Therefore, they need to give maximum attention to the diet, and nutritional status of all age groups in Nigeria is very critical at this period and calls for emergency. So the vicious cycle is here. Is a diagram, and since I'm not able to share my screen, you can have the presentation.
I think you can try now. We have enabled you.
Okay, sharing screen. Let me see. I'm sorry, it's not coming on. And so this is it. Combating the COVID-19 pandemic, we take advances in many fronts, and plant biotechnology is required for some of the most discussed urgent needs, including the need to foster new treatments, vaccine, and then nutritional enhancement of food crops. Dr. Egezu will give us details about nutritional enhancement. Please, can you mute your mic? The development and application of biotechnology in plants and animals offers novel possibilities that could facilitate nutritional enhancement of stable crops and so on and so forth. Recent advancement in this plant transformation and transgene expression technologies can also facilitate the use of plants as bioreactors to produce a variety of bioproducts at large scale and low cost. So such byproducts could be effectively used as treatment or vaccines. So I have another picture here again. I think I have to rush. Though dietary supplementation with multivitamins, bioactive lipids, flavonoids, and herbs may be a tool to support the human immune system against COVID-19. Such nutrient-dense foods are often not accessible by the poor and rural inhabitants due to cost and ignorance. So the deployment of biotech tools can enable plant breeders, engineer plants, most especially oh, okay, you can move the slides.
Okay, ma.
Please, since I can't move it from here.
Okay, I'm moving already.
I've gone far.
Okay.
Just be moving. Move. Yeah, I've passed this place. Yeah, I've passed here too. Yeah, I think I've passed here too. The next one. Okay, yeah. The dietary supplementation, I think I've read this. So the deployment of biotechnology, I'm coming. I have to move this. Something is covering my screen. I cannot read some other things. Can you? Oh my God.
No.
I can't read. It's not everything I can read here.
Ma, can you maximize your screen?
It's maximized, except if I can minimize. I think it's better you just leave me the way it is. Let me just finish reading.
All right.
Can you close it? Let me just have it the way it was. Okay. Okay. The deployment of biotech tools can enable plant breeders, engineer plants, most especially staple crops such as rice, cassava, corn, and others to express such vital micronutrients that are necessary to boost the immune system with also reducing costs and making it available to everyone. I have the diagram here too, which is just an example of some of the crops that can actually be modified, genetically enhanced with nutrients. You will hear more from Dr. Egezi, who has perfected biocertification of cassava. And it's just examples of crops that could be, bio-fortified with nutrients, at least to help curb malnutrition in children and all. So in conclusion, I think in the near future, biotechnology can revolutionize the way we think. Technological advances have dramatically triggered the rates at which plant transformation can be achieved to meet our specific needs at every phase of life. So the rapid drop in the cost of whole genome sequencing and synthesis technologies means that scientists can now carry more research much faster and at a lower cost, especially the gene editing technology, which is the newest one, and I think it can actually help. It's cheaper, it's faster, and all. It's less cumbersome, and it takes less cost and all those things. And then you don't have to move gene from another plant to another one. You can work within the genome system and then have what you want. So those challenges of regulatory roadblocks and stiffened processes of approval will continue to remain major challenges for aspiring biotechnology innovators. The future looks bright, of course, for agricultural biotechnology researchers, most especially in developing countries like Nigeria. Continuous advocacy and tailored scientific communication that would mostly target policymakers and stakeholders of the agricultural sectors, the farmers' needs, to be amplified in a time like this. And this is actually one of it. And so we need to come up like the scientists, amplify our voices and speak in advocacy to the nooks and crannies of Nigeria so that we can attain, so that we appreciate this technology that is very useful, that has changed the status of many countries like India, like Japan, like Argentina, US and all those, even South Africa here in Africa. So Nigeria has joined the queue, and I'm sure it's going to be for the better. Sooner or later, at least, will be food secured. Not just food, having the food, but having well-nourished food. Nutrition and food security. Nutrition is topmost, should be topmost. So that our immune systems will not be compromised. So that our children will grow up very strong and vibrant. So I think I have ended. I hope I have beaten the 10 minutes that was given to me. I think I've tried. This is the fastest presentation I've ever made. So thank you, one and all. We'll hear more from Professor Chidozie and Dr. Kolo. I hope Kolo has tuned in. I've seen Mrs. Akeju. Mrs. Akeju, well, you're welcome from FCCPC.
Thank you, my Dr. Gado. Nice to see you.
Thank you. I joined. I was able to join, Rose.
Okay, all right.
Yeah, I just took off the video so that the sound will be okay.
Okay, thank you, Dr. Gidado. Hello. Thank you, Dr. Gidado.
Okay, thank you, sir. Thanks so much. Sorry.
Now, although you use more than 10 minutes, but we appreciate the hitches that you encountered. I think because of the time constraint, we may not take the advertorial now. We'll just go straight to Professor Chidozie Egezi's presentation.
Okay.
So, Professor Egezi, are you on?
Thank you, Prof.
I hope you heard.
Good afternoon. And good afternoon.
Please, can you allow him to share his screen? Don't do like my own.
Yes, thank you. Thank you, Dr. Rose Gidado. Beautiful presentation, but mine can't go on without sharing the screen.
So that's the thing.
So it's very simple. Click on the green arrow. If you click on the green arrow,
He should be able to.
I still can't.
We don't know what's happening.
Abraham, do that.
Please do that. We need to see.
But you also have my slides, so you have the choice to show it.
Yeah, that's what I'm saying. Abraham, can you share it from your end?
Yes, I'm trying to see this. Check the settings.
So please, while Professor Egezi is getting set, I would like participants to drop their questions. And the Secretariat, please, Abraham and Alex, you try and capture the questions for and draw it to attention of the various different presenters. Gezi, are you on?
And then that's very nice. So it will be good to be specific. If you are directing a question to Dr. Rose, you just put Dr. Rose, then the question they will channel it appropriately.
I think I'm seeing questions here. I can even answer them here in the chat box. Okay. Abraham, what are you doing?
I think maybe
what's happening?
We are seeing this screen share here, but it's still showing host not allowed to share. Probably technical issues, but we are still working on it.
Share. Can't Prof share from his place?
Yes, Prof, please can you try it one more time? Can I give you?
Not working. So there's a place you need to enable it for me to share. You have not clicked that.
Abraham.
I can't share.
Abraham, can you add him as a host?
He's a host. He's a host. Just saying that.
Yes, he's a host.
You add Gezi as a host.
He's a host already.
Okay, okay.
I've opened the presentation from here as well. Let me see if I can.
Because if you're clicking on the share, you should be opening it here. But it's already to log into your Zoom from here. I'm sure I'll open it.
Hello, everyone. Can you hear me?
Yes, we can, sir.
National.
I'm checking. Have I shared?
Yes, ma'am.
Have I shared?
Yes.
Okay, so let me run it from here.
Okay, can you put it on slideshow, please? Put it on slideshow.
Okay, I'm coming. I'm looking for it.
Why is
All
right.
Yeah, I put it on slideshow. Is it okay?
Yes.
Yes, thank you.
Right.
Thank you now. I would have loved for everybody to mute their mic, please, everybody, including the moderator. And everybody mute their mic. It will be helpful for all of us. Thank you.
Because I'm sharing, I don't want to take the chances of
You can mute your mic. Okay, but if you don't, that's fine.
Yeah.
All right.
Yeah.
Thank you. All right. Thank you, everyone, and welcome. I believe that Professor Alex Akpa has left, but Professor Alex Akpa, the DG, and ABDA, Professor Emmanuel Kwandong, the President, Genetic Society of Nigeria, Dr. Isufu Kolo, the Regional Director for AATF West Africa, Mrs. Akeju, the Director for Quality Assurance and Development, the Federal Competition and Consumer Protection Commission, Abuja, and Dr. Rose Gidado, the Country Coordinator for OFAB. And there are a lot of other colleagues, scientists, some from my institute at Ibadan, IITA, and some from also my home institute, NRCRI. I want to welcome all of you to this talk. The title is is mouth-filling, but it's a summary of how to boost our immunity to infectious diseases using plant biotechnology. And it involves, I mean, when we say diseases, COVID-19 is one of them, but it's not the only disease that is of concern to us. So can we go to the next? Okay, no, before you go, I want to acknowledge that this talk is a work that is being done by myself and Dr. Ihuoma Okwono here at the NRCRI. So I am I'm a man of dual part. I work at both NRCRI and IITA for your information. Please go.
All right.
Next slide, please.
Okay, next slide. Not this. Is it okay? Is it okay?
Yes, okay. So in Nigeria, there are at least 5 million malnourished people that we can see, and there is an indication of people who are compromised. And this study is just being conservative. Almost all of us are lacking in one important nutrient or the other. And at least most of the people, the vulnerable ones are the women and children under 5. And these are also from smallholder farms. So as an agricultural scientist or researchers, our own effort is to see how to manage these diseases by the food we eat. You know, the food we eat can be the medicine that we need, and we don't need another medicine. And that's the whole, what this talk is going to be about. Next slide, please. Next.
What is?
So I know what's happening, Rose. So look at the bottom left. Can you listen, Rose? Look at the bottom left. That arrow. Just be using the arrow. The arrow alone is fine.
Yeah.
Go.
I should go again?
No, that's fine.
All right.
So Nigeria is the largest producer of cassava in the world. At the moment, we produce over 54 million metric tons annually. And cassava is an important staple for many of us. In Africa, it's also important. About 500 million people are depending on the crop. Please, next.
All right.
So that we
Okay.
were able to.
Let me just.
Many use of cassava. You can see gari there, you can see flour, you can see abacha, even bread, or whatever. So all that families can eat it in various ways, and some families are actually 3 times if they can afford 3 square meals. Those 3 square meals can be cassava in some places in Nigeria or in Africa. And you know, I've said the different areas. Please, can you go to the next slide?
All right. I'm there. I'm there. I'm there.
So you're going to see slides that are alternating, and it may not be in the order you would expect, but there are issues with cassava and even with our country. And we have a continent, not just Nigeria, a continent that is bedeviled with a lot of burden, diseases, but they are caused by insufficient or incomplete nutrition. Micronutrient deficiency comes with a burden that makes people more susceptible to diseases because of poor immune systems. It can result to stunting, wasting, and disability, permanent disability in some areas, or cognitive ability. That is, you know, you have children that are not very sharp in the way they appreciate knowledge. Please, next slide. So cassava is a high energy crop in the terms that it can provide you with more than 80% of the calories that your body needs daily, but it's lacking in essential micronutrients that are good for your healthy and productive life, such as vitamin A, iron, and zinc. And micronutrient deficiency can actually impair our body's immunity to diseases such as COVID-19. And nearly 1 in 3 Nigerian children under 5, or a quarter of pregnant women, reproductive age women, are deficient in vitamin A. Let's go to the next slide. You have to be fast with me, Rose.
All right.
Right. So a few years ago, Rose was saying the right thing. About 10 years ago, we published a paper that we made that study in Nigeria. And it says children consuming cassava as a staple food are at risk for inadequate zinc, iron, and vitamin A. In Nigeria, the data you see on the top right, Nigeria. So we have this range of deficiency from 20 to 80% of children under 5 are really iron deficient, depending on the area you survey or sample. And the same applies to pregnant women, 20 to 60%. For zinc, about 20 to, so the least case is that 20% of our population, or if you go to the middle, is like half of our population are deficient in these minerals. Please, next slide. Another study that also shows the same thing, that 30% are 30% of children under 5 are deficient in vitamin A. A quarter of Nigerian children, this is very crucial, the government should listen to this. A quarter of Nigerian children are iron deficient. That is, they're anemic. Another 20% is zinc deficient. And have we heard about, I don't know how many of us have heard about the relationship between zinc and immunity or resistance to COVID-19. But we'll get back to that. Please, next slide. Right. So there's something you will call the burden, the cost of these deficiencies. So when a population is deficient in iron, it predisposes them to malaria, worm infestation, and infectious diseases such as COVID-19, HIV, or TB. Iron deficiency anemia affects the immune system and stunts growth and impairs cognitive development in children, just the same way that vitamin A does it. 50% of pregnant women and 40%, that's half of our pregnant women in developing countries, and Nigeria is one of them, are anemic. And that is something that is very serious. Now, you talk about zinc deficiency. It leads to physiological disorders affecting our immune system. Everything is talking about the immune system. But remember, we are not going to, in this today's talk, we're not going to be talking about pills, that's tablets or medicines. We're going to be speaking about how we use food to circumvent this. You will see the burden that it costs Nigeria $1.5 billion to our GDP, what the deficiency of vitamin A, iron, and zinc. That's the cost. And this is according to World Bank. Please, next slide. It's a lot of cost when you deal with that. But Nigeria is doing something. Years ago, and that's like 7 years ago, a national policy on micronutrient deficiency control in Nigeria was launched by the Federal Ministry of Health. And good enough, for the first time, there was an intersectoral collaboration between the Ministry of Agriculture and the Ministry of Health. And among the many things that were written out as solutions, there was fortification, there was supplementation, and all the other, even food diversification. But it's important, and for the purposes of our talk, to know that Nigeria, in that document, recognized biofortification as a sustainable intervention strategy to manage micronutrient deficiency. Please, next. Next slide, please. So we need to enhance the nutrition of cassava. Remember, I told you earlier that cassava can provide you with more than 80% of your calorie needs, but it is going to provide you with less than 10% of your vitamins or minerals. And the ways to manage that, if you're not using biofortification, is through supplementation or fortification of our food, like we have processed products. We add vitamin A to salt and iodine to salt, vitamin A to sugar, vitamin A to flour. But biofortification of crops can take place either by adding mineral fertilizer or through conventional breeding or biotechnology. And all these avenues are very good. But for our purposes today, we will not be talking about mineral supply of fertilizer, supply of fertilizer for minerals, or we won't be using conventional plant breeding, because we have used that in the past and we have successfully used that. A few more slides will address that. So in about 10 years ago, or 8 to 10 years ago, we worked with a project called the Harvest Plus project. Harvest Plus is now an organization, it's no longer a project. So we're able to use conventional plant breeding to develop vitamin A cassava. And those varieties we've released, 6 of them, are being grown by Nigerian farmers. Millions of Nigerian farmers are growing them now. And it's important to note that those cassava are the ones called yellow cassava. It's also important to note that those are not biotechnology produced, but we know that vitamin A is not the only deficiency. Remember, a quarter of Nigerian children are suffering from iron and zinc. So the problem now is that we have limited genetic variation to develop those varieties with high iron and zinc. And so genetic modification provides us with an alternative pathway to introducing these traits of iron and zinc into our farmer preferred varieties. Please next. Next slide, please. So using biotechnology, we can genetically modify cassava to increase the levels of iron and zinc, and we've been able to do that. So great progress has been made in the application of biotechnology, especially to generate nutritionally improved food crops, especially staple food crops like cassava, even rice and sorghum. But with this technology, genes of interest can be inserted directly into the plant genome, and it's faster, it's cheaper, and it's cheaper than some conventional plant breeding programs, actually. Please go to the next slide. There are other technologies I may not talk about, but it's good to use this. Just one slide.
Others, I can hear some talks behind the scene.
Thank you. So there are other technologies that we may not really go into today, but it's good to highlight that it is an emerging technology that is genome editing. And with genome editing, you can introduce your trait, your gene of interest, and it is of higher precision, and is an alternative to genetic modification that the world is using to generate. I'm having a lot of noise in the background, and I think a lot of people have need to mute their mics, please. I have Robert to mute his mic, and Sarah, if you can mute your mics, that would be fine. Thank you. Next slide, please. So I'm going to introduce us to a project. Hello. I'm going to introduce us to a project called VICA Plus. VICA Plus is a product development project, and VICA stands for Virus-Resistant Cassava in Africa. And the plus there represents a nutrition, an addition to nutrition. But the goal of the project is to enhance the livelihoods of smallholder farmers that by delivering cassava varieties that have been genetically enhanced to resist virus diseases and at the same time provide elevated nutrition. Please next, click the next, because it's, yeah, and the next two. So resistance to, the two key goals of the project are, no, go back.
I should go back.
Yeah.
No, let's go back.
The arrow that is saying go back.
Okay, you know the arrow disappears.
One more. Right, thank you. Just leave it. So there are two goals. To develop resistance to cassava brown streak disease, that's what CBS stands for, and cassava mosaic disease for deployment in East Africa. The second one is the one that concerns us today, and that's the one we are doing in Nigeria, to introduce virus resistance with high iron and zinc into the cultivars that we are growing. And right now, and the aim was to do field trials of Nigerian varieties. One of them is TMS 980505, and another one is TMS 912324. They have resistance to virus, CMD, and we only need to introduce the high iron and zinc into it and then grow it in Umudi. If you look at the two arrows, those are the two Nigerian scientists. The one at the back is myself. The one at the front is our champion, Ihoma Okwon. Next slide.
All right.
So can biofortification really boost immunity to diseases, and can it work? Yes, we've been able to prove it with vitamin A, and there's been a demonstration that when you consume high biofortified cassava with vitamin A, it increases your immunity. And that has been proven not only in cassava, even in sweet potato and other crops. So next slide.
Should I?
Next slide, please. So this is a walk, and I don't want you to deal too much on some of the scientific terms there, because I know not all of us may be scientists, but for the ones that are scientists, these are the genes that are used, that were used initially to do that. So it's overexpression of the zinc transporter gene, and overexpression of the IRT gene and the FER ferritin gene. But we discovered that overexpression of the IRT gene assisted in zinc, elevated zinc at the same time. So we left this one and we moved on to use only the last two. Please, next slide.
All right.
So we first tested these materials that were developed with our partners in Danforth Center, US, at the University of Puerto Rico in Mayagüez. There is an island in the US, or a territory of the United States. And these are the crops. These are the same varieties with TMS 98/980505. Please, next slide, just to show that these materials were tested before they were even sent here. So this is the material. Please just click the next so that I have the other figure. Yes, stop. Yes, stop. Yes, stop. No. So if you look at you can see my arrow. Rose, if you can click, if you take an arrow to the WT, which is to the left side of the curve of the WT is down, down, to the left, down to the left.
To the left.
No, down to the left. Yeah,
so
WT is white type. So it is our cultivar that was not transformed. So see the level of iron, compare it with the other ones that are towards the right. Some of them are 9 times more. The same thing for zinc. You will see that the ones in black box are very low compared to the ones that we've transformed 10 times more. Please, next slide. Don't worry too much about these slides. I'm going to explain them. So we also checked, is it just to carry it in the roots? It's fine, thanks. Is it just to carry it in the roots? We transform this to gari and fufu, and we process gari and fufu from the transgenic and the non-transgenic. And we saw, I think, 70%. Somebody is talking. Are you talking to me?
Please, can you mute your mic?
Please mute your mic. Mute your mic.
Who is that? Can you? I can't see because my screen is blurred.
Akimade, please mute your mic. Okay, so I'll go on. So it's just to say that we observe 70% retention of iron and zinc.
Okay, I'll do that.
What do you mean?
Can I continue?
Opposite to
Please, Abraham, can you mute those talking? Mute them from your
if you take from pass entrance, then you go straight. You not take step. You go right. Go right. Those offices are. You come down, check second, or you check first. It's either one of the three. On ground floor.
Can I continue?
Yeah, you can.
All right. So next slide, please.
All right.
So please click one more for the other. Yeah. So all right. Okay. So when you look at this, remember where we are coming from. So we know already that the cassava we eat, that's a non-modified one, the non-genetically modified one, is providing less than 10% of the requirement of our less than 15% for zinc. And we found out that with the retention and bioaccessibility studies from our own studies of these genetically enhanced iron and zinc cassava varieties, that we, from the gari and fufu and even from the roots, we saw that we can have at least 50% or at least 40% of the requirements for iron and 60% of the requirement for zinc for children under 6 years and even for women that are of reproductive age. Please, next slide. So now back home. No, can you go back?
Yeah.
Back home. So we have these materials already. Okay, you're sharing the wrong slide, but it's okay. I'm fine. The first and second bullets are the same. We changed that, but it's okay. It's not a big deal. The trials are now growing here at Umudike, and we have materials that are having resistance to brown streak disease and iron and zinc, and some that are having only iron and zinc in evaluation for trait performance. Please go to the next slide. Now, our plan, this is also our plan. This is not yet happening. What we plan to do is to take, when we confirm these materials, we'll be able to make crosses between these new lines and our local lines that are being grown by farmers here or that we've developed over the years, and do breeding and be able to, put the different traits together that combine high yield, resistance to other diseases, and high dry matter. I think that's all I would like to say on this slide for now. Next slide. So we have other future plans there, but they include to run these trials in different locations. So you see here, let me not run them. As you see them, you can relate to them, but everything is needed here for us to be able to release this variety to the farmer. So every plan that we have here, a similar thing was done for the BT cowpea by our IAR partners in Zaria. They did this number of activities to be able to release. So these are the things we need to do. And these are in our plans for the next 3 to 5 years, depending on how everything is going. But we are targeting that within the next 3 years, we would have done a lot of these trials in Nigeria and be able to come to the Variety Release Committee and say, please let this variety be released to Nigerian farmers. And then other farmers in West Africa can begin to leverage on it. Please go to the next slide. Remember the arrow, yes. So in summary, I just want to tell us the burden. Again, it's not on the slide, but you know that a lot of people take zinc tablets to help support their immunity. By gari or fufu, or if we are able to give them iron and